Alright, welcome back to the next section. Amazing hackers will talk about the basics of security. These are things that everybody should know about. Some of these concepts will go deeper into the design patterns, but for now we'll look at the basics first. First of all, it's very important that you use TLS. HTTP, FTTP. If there's not an S at the end of it, I don't want to hear about it. Now, that's a little bit of a joke, of course, but it's sort of true that all of these protocols, they, especially in these days, it's very easy to secure your HTTP connection. So HTTP should definitely be a no-go, and you should always go to HTTPS wherever possible, especially if you're dealing with sensitive data. So you will stop man-in-the-middle attacks before they even happen, and this is very, very important. Now, as for cookies, they have a certain flags that you can set on them. You can set the HTTP only flag, which means that the cookie cannot be used by JavaScript. This can prevent things like cross-site scripting, stealing session cookies, for example. You have the session flag, which means that after the current session, the cookie will be destroyed, of course. You have the secure flag, which means that the cookie can only be served over a secure connection. And then the host only flag, which means that the cookie can only be used in the current subdomain. No other subdomains of that domain can use that cookie. So that's important to know. If you're struggling a little bit with sharing cookies between subdomains, that might be why it's the reason. Now, it's also very important to test every single piece of user input, and you want to do this on the front end, back end, and in your database. I know that most applications these days consist of a front end, back end, and in the database. So you should also implement security on all levels, and that means testing its user input on all levels. And this might be very easy to say, test user input, but you really have to test every single piece of input there. So that's hidden inputs as well, file names, file contents, even an identifier can be vulnerable to things like reflected cross-site scripting if it's a get parameter, for example. And if it's reflected anywhere on the page ID equals blah 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 not found, well, then you might open yourself wide up to cross-site scripting attacks. File content, sometimes if you display it on a website, of course, parameters that are live but not used. And then headers as well. Now, those parameters that are live but not used may surprise you, because how would an attacker figure those out, right? But security through obscurity doesn't work, and you always have to assume that your system is compromised. You really should never allow for flooding, which, for example, would allow an attacker to enter a massive amount of data into your application and then shut it down completely. We call this application level denial of service attacks. And to do this, we want to restrict user input again on all fronts. So that's front end, back end, and database level, and against all possible parameters, the same that we saw before, of course. On we move to the encryption part, and we already talked a little bit about this with the TLS part, but I also want you to use more encryption wherever needed. If possible, for example, banks, when doing money transfers, they implement extra encryptions to make sure that you're not just, some banks at least, they will encrypt the request so that you can't easily manipulate it, but actually have to decode it every single time. That's something that they can do. For example, base64 encode, that's a very simple encryption mechanism, and we can easily decode that, of course. But still, it's an extra step, and it's usually not as easy as base64. They will have their own proprietary algorithms for that. These kinds of things really stop man-in-the-middle attacks before they even happen, because of course, unless the attacker is able to slip their certificate into the victim's browser, then it's gonna be very difficult for them to actually read the traffic that they're intercepting. Even the URLs, those are also encrypted, by the way, over HTTPS, for example. Now, it's important to use multi-layer security. This is where you give everyone, you assign them to the group, and you give them that group, preferably the proper access levels. We really don't want people snooping around in locations they shouldn't be, so we really don't want them having any rights that they shouldn't have either. And whenever they leave the company or whenever they join another team, adapt their rights accordingly. So that's very important because I've seen plenty of companies where this doesn't happen. Or where they just give you admin to everybody. I know it's well intended, but ethical hackers like me could come in and they could rip your entire database and they could send it over to somebody who's paying me a hell of a lot of money. I would never do that, but unethical actors, they might have an incentive of money to do that. You really also want to use well-known libraries, and especially for things like encryption. Really don't try to figure these things out in yourself, especially if something exists already. You don't want to reinvent fire. And this is very important because you really don't want to open yourself up to vulnerabilities in your encryption algorithm either. So those well-known components and libraries, they will have been tested properly as well before, which is why I think it's so important to use them. Often they're also open source, by the way, which further increases their security level by a bit. It's not huge. I know that a lot of these open source projects have a few dedicated contributors and actual code reviewers, but still it's better than nothing. Now, make use of delays and rate limiting whenever possible. You really want to prevent denial of service attacks, whether they be from one computer or distributed. You really don't want your application to go down because an attacker decides to unleash a storm of requests into your application. This also prevents password stuffing and also prevents brute forcing of passwords. And this is required in my opinion. And you really want to create maybe like a gradual backup mechanism where if they enter their password incorrectly for 3 times, they have to wait for 3 minutes. And if they enter it incorrectly, they have to wait for 10 minutes. But you really also don't want to allow the victim to be a real victim of this by the attacker being able to lock out the victim's account. So this means that you're actually locking on IP basis. If this IP is making a request again, he's made 5 incorrect attempts, so he's waiting at least 10 minutes, for example. Of course, you can create your own interpretation of how this would best suit your company. Now, you really also want to build security walls. This can be, for example, retyping your password, verification of a birth date, verification of the last 5 digits of a phone number, something like that. And it's important, and I know that nobody likes to re-enter their password 50 times over, but it's better than having your account compromised, in my opinion. And this is mostly applicable on high sensitivity actions, things like buying actions, changing passwords, changing email addresses, things that could compromise the account basically. So for these things, it's really vital that you build your security walls well around him. This is to further decrease the impact of an attack as well, of course. That's mostly what this is intended for. Now, if we move on to APIs, it's a good thing to split up your APIs from this one big monolith into a lot of micro APIs, because those micro APIs often will be easier to reuse. They'll be easier to properly code review, to unit test in small chunks, and to also integration test. The smaller the better, in my opinion, and this will allow you to give every API only the exact required privilege levels and nothing more than that. More about that later. And as for peer reviews, it's important that you really don't skip those. Make a branch, create peer review, and only then merge to master. Because you never know, maybe the CI/CD pipeline runs and it actually goes to production with a big vulnerability in it. Do it thoroughly, very thoroughly. Look at it from not only a functional level, but also a non-functional level, meaning performance, security. You guys know software has quality characteristics, but this is not the course for that. Make and update a checklist for your code reviews as well. And I know this sounds silly, but keep it very general, very brief. Don't go very deep into details. But it's these types of checklists which are also used by code review tools, and your team will have specific vulnerabilities Coming up from the past, well, maybe you can form them into a checklist item, for example. But I really want to emphasize that these checklists are living entities and that you don't just create and forget about them. An outside reviewer or an outside auditor might also be a good idea here. Now, there are some code analyzers, SonarCube, Findbugs, perfect if you use them, but use them alongside manual work as well, because nothing beats the eye of a trained ethical hacker, in my opinion, at least no tools. The path of least privilege is where we give every single process, every single function, every single user input the exact required privileges and nothing more than that. Exactly what is required for the application to function as it is intended and nothing more than that. This might seem easy, but the devil is in the details. If you want to apply this to a big level, it's going to cost you a lot of money because, of course, you're going to have to map out every single process and what the required privileges will be. Otherwise, you cannot actually enforce them. So again, that's going to take a lot of time. Time is money. But if you want to do this right, this is the best option in my opinion. Don't leave credentials in, default credentials. Don't use easy, lazy credentials if you push anything to anything but your own computer. Even for your own computer, don't use weak credentials in my opinion. Don't leave them in. Do I really have to say more? If I do, I think you might need a different course. Update often and enforce the update policy. This is very important because this might seem easy, but you have to take into libraries into account that you're using and their libraries as well. But you also have to take into account that those libraries might be using other libraries with different versions on them that are outdated and weak. So it's important to really keep an eye on what versions of software you're using and to at least install all security updates and enforce that across your whole organization on your whole library as well. Now, for the passwords, you can keep them in several locations I've seen throughout my career. One of the worst places is to keep them in a file, in a config file, for example. The best way to go about this, in my opinion, is to put them into an environment variable, and that's because if you put them into an actual config file, and that config file ever goes public, well, then you might have a problem. And the thing is that config file, it might need to be public for whatever reason, might need to contain a password, and that means a public password got leaked, which is a very severe issue, of course. I mean private password, but the password becomes public, of course. And again, sometimes you want to then separate your password policies and your code policy, your file, config file policy. So that's why it's important to also separate your passwords from your files, of course. And like I said, I would store them in session with variables on my target. So that's it for a general overview of security. I think you guys have a better overview of what it takes to actually secure your code. Now, next up, we're going to look at some examples.